Assalamualaikum warahmatullahi wabarakatuh and very good day. So now we continue with our lesson. So we'll discuss about the higher viscosity and also density effect of biodiesel. First, effect number one is due to the high viscosity and also density of biodiesel fuel, it will cause high deposit formation in an engine. As shown in the figures is the result they obtained by Kondo et al. 2008, where Kondo et al. Conduct investigation about the carbon deposit formation due to rapeseed methyl ester (RME) or rapeseed biodiesel fuel, and also the formation of carbon deposit due to diesel fuel. So from the result show that the biodiesel fuel rapeseed methyl ester will have higher amount of carbon deposit accumulated with the investigation compared to typical diesel fuel. So if this pattern of deposit formation occur in an engine, especially at the at the injector tips, it will cause poor injection during the combustion process. So this photo shows the good injection spray, where we have a nice spray pattern. If we take closer look at the injector tips, we can see that there are 6 holes at the injector tips, and we can see that the injector has very clean tips without any deposit at its holes. Compared to the second figures, we have poor injection, where we have inconsistent spray pattern, and if we take closer look at the injector tips, we can see that all the holes at the nozzle tips are covered with fuel deposit. Effect number two, the higher viscosity and also high density of biodiesel fuel will cause larger fuel droplet size, where this will cause poor atomization. So during fuel spray, before the combustion process occur, so poor atomization will refer to the formation of bigger droplet size, and good atomization will refer to the smaller droplet size. So when uh, the fuel spray introduced by the injector, so actually the spray pattern consists of thousands of fuel droplets that will impinge on the wall of the combustion chamber. And due to the larger fuel droplet size, also will cause poor vaporization during the combustion. So this will cause a lot of unburned fuel remain on the surface of the combustion chamber. So the figure shows the process of vaporization when the fuel droplet impinge on the hot surface of combustion chamber. So due to the poor vaporization, more liquid fuel remain on the surface of the combustion chamber, and further will cause higher formation in terms of amount of deposit on the wall. So this behavior affect the combustion behavior in diesel engine. Effect number 3 is incomplete combustion process. So the figure shows the effect of incomplete combustion process, where we have the formation of deposit that refer to the black particle inside the combustion chamber. So combustion is incomplete due to presence of larger fuel molecules and insufficient fuel oxygenation. Okay, so the second figure shows the combustion process. So first we have primary atomization, where the fuel will spray thousands of small droplets into the combustion chamber. And then the second process, due to the high temperature and pressure, the fuel particle or the fuel droplet will combust. However, part of the droplets still not combust due to the incomplete combustion. And then, due to the incomplete combustion, the process will produce soot, the black particle, carbon particle, and also smoke, plus water vapor, which is the side product of the combustion process. Effect number 4. So, due to the higher viscosity and also density of biodiesel fuel will cause greater spray penetration. So, in order to understand the statement, we need to know the what I call the characteristic of fuel spray. So, we have in the figure we have injector. Theta represent the spray angle. So, we have fuel spray. So tip penetration actually the distance from the injector tip until the end of the spray. So, due to the high viscosity and density, biodiesel fuel will cause what I call will increase the deposit formation tendency due to the greater spray penetration during the combustion process. For example, the first figure shows the standard spray penetration, where we can see that this fuel spray did not impinge on the combustion chamber wall. Most of the fuel vaporized during the combustion process. However, if we have a longer or greater spray penetration, probably during the combustion process, part of the liquid fuel will impinge on the combustion chamber wall, and this will increase the tendency of the deposit formation. Okay, higher viscosity and density effect of biodiesel fuel. Number 5. Effect number 5. This properties will cause longer evaporation time. So as we can see in the figures, the figure shows what I call the characteristic of droplet evaporation during spray what I call formation in the combustion chamber, where we can see that what I call the diameter of the droplet reduced due to the evaporation. And this what I call longer evaporation time will cause the delay in the combustion process, as shown in the figures. What I call the bottom view of the actual combustion chamber for the standard operation, where we can see what I call the formation of burning section due to the combustion process. So from this figure, we can see that in terms of numbers of holes of the injector, so we will have around 6 holes. That's why we have 6 what I call fuel injection during the combustion process. So from 4 photos, the combustion start at photo number 2 for standard operation, where the combustion process without any delay. So the process according to the design process of the thermodynamic process in the engine. However, due to the longer evaporation time, the combustion probably will start at photo number 3, okay, as shown in the slide. So the combustion already delayed to the longer evaporation time of fuel that we use in the combustion process. Effect number 6, I call the higher viscosity and higher density of biodiesel fuel probably will cause engine knocking. As you can look in the figure, shows the pressure profile versus what I call rotational angle of the crankshaft. Where we can see that there are 1, 2, 3, 4 regions, important regions in the graph, where we have first region, ignition delay region number 2, rapid combustion region, region number 3, control combustion, region number 4, afterburning. So our concentration uh, for the figures is for region number 1, also region number 2. So due to the long ignition delay during the combustion process, large amount of fuel will enter the combustion chamber. Okay, so this will cause due to large amount of fuel burned in the combustion chamber, so we'll have instant pressure rise. So this process shown by the second second graph, where we have fluctuation pattern of curve due to uh, the pressure increase and also pressure decrease during the combustion process. And this will cause violent gas vibration, and knocking process will occur and produce loud noise during engine operation, and will cause mechanical damage. Heat transfer will increase, the efficiency of the engine will reduce. Solution for biodiesel fuel properties effects. So from the previous slide, we know that biodiesel fuel properties in terms of density and also viscosity change the combustion behavior in diesel engine. So in terms of solution, we need to reduce the differences between biodiesel fuel and also typical diesel fuel in terms of its physical properties. So bio-blended diesel fuel such as B5, B10, B20 suitable to use in order to obtain similar properties as diesel fuel. So so we need to have similar spray behavior when we use so we need to have similar spray behavior as typical diesel fuel when we use biodiesel fuel. So investigation conducted by Hong et al. 2019 investigate about the spray pattern, the similarity of spray pattern between biofuels and also diesel fuels. So the figure shows the spray pattern of diesel fuel with spray angle 21 degree and spray penetration with 205 millimeter. However, for biofuel, the investigation found that the angle of spray is less compared to this typical diesel fuel, around 10 degree, and the spray penetration is greater compared to the typical diesel fuel, about 270 millimeter. However, when the biofuel in terms of fuel temperature slightly increase, so we try to preheat the biofuel before entering the combustion chamber, so we will get the spray angle and also the spray penetration is almost similar with the typical diesel fuel. So spray angle at 20 degree and spray penetration at 209 millimeter. So for this investigation, preheat biofuel has quite similar in terms of spray behavior. So we want to have this kind of similarity before we introduce the biodiesel fuel into the diesel engine. And also we need to have similar what I call similar in terms of emission after the combustion process in the diesel engine. So the investigation that conducted by Rakopoulos et al. 2006, this investigation conduct an experiment to measure hydrocarbon emission for diesel fuel and also different type of biodiesel fuel. So we have the comparison in terms of hydrocarbon emission for diesel, cotton-based methyl ester, soya-based, sunflower-based, rapeseed biodiesel, palm oil-based biodiesel, and so on. So if you look at the graph, the first column represent the amount of hydrocarbon emission released by diesel engine if you use typical diesel fuel in the engine, and compared to other type of biofuel, biodiesel fuel, and also vegetable oil, pure vegetable oil based on cotton oil, soya oil, sunflower oil, corn oil, and olive oil. So we can see that the amount of hydrocarbon emission through the engine from the engine quite similar, around 80 ppm. Okay, so these are example of similarity that we need to have before we use the bio blended diesel fuel in our actual diesel engine. Okay, now we will discuss about fuel deposit in engine, which is one of the effect due to the usage of biodiesel fuel in diesel engine. So the figure shows the schematic diagram of combustion process in an engine. So we can see that the surface of the combustion chamber covered with black particle, and this black particle normally due to the incomplete combustion process. So we have a deposit accumulation on different part of engine. So in the figure shows the fuel deposit on cylinder inner surface and also fuel deposit on the piston head. And normally we'll have what called carbon deposit. So the black particle actually refer to the carbon deposit. Normally this material come from uh, the usage of what we call high density and high viscosity fuel, such as biodiesel fuel. And the carbon deposit actually is the heterogeneous mixture that consists of carbon residue or ash, carbonaceous mixture, soot, and also resinous organic material. And critical deposit location in the engine are, so this figure shows the cross section of the actual engine. So the first critical part of the deposit formation is on the valve surface, on the piston, normally on the piston crown, cylinder head, and also at the injector tips. So these are the area, the critical area. Normally we can found most of the deposit formation will occur in the engine. Okay, fuel deposit mechanism based on suggestion by Lepperhoff et al. 1993. So the figure shows the simplified schematic diagram of cross-section drawing for the combustion chamber. So we have intake valve and also exhaust valve. We have injector that produce a fuel spray. We have piston and also chamber walls. So there are two type of mechanism. First mechanism refer to the deposit formation mechanism. So the first process is the formation of the thin film where in the combustion chamber, so we will have condensation of gases component due to the reduction of temperature, gas temperature inside the combustion chamber. So from the vapor or gas phase, the fuel will change into liquid film and will attach on the chamber wall. Next, uh, the particle that produced during the combustion process will impact on this thin film, and the particle will stick inside the thin film or on the surface of this thin film. And these two process we refer as the induction phase of deposit formation. Next, after the I call the second process of induction phase, so there are the absorption of gases component that absorb into the deposit formation on the chamber wall. And due to the compression of the layer and also the reaction of the hydrocarbon, so we will have black color deposit. that attach or stick on the chamber wall. So these are four process involved with deposit formation. And the last two process we refer as deposit growth phase. Okay, the second mechanism is referred to the deposit removal mechanism, where these two mechanism, deposit formation and also deposit removal mechanism, will continuously occur during the combustion process in diesel engine. Okay, so for deposit removal, we have different type of deposit removal. First type of deposit removal is due to the oxidation of soot particle and also oxidation of hydrocarbon inside the deposit that stick on the chamber wall. So the second type of deposit removal is due to the evaporation of volatile fraction in the deposit. So part of the liquid fuel that trapped into the deposit will vaporize, and this will reduce the amount of or the mass of fuel deposit that attach on the chamber wall. And the third deposit removal process is we call desorption process of the gases component, where part of the uh, gas maybe that trapped in the deposit will release due to the desorption process. And due to the abrasion process, maybe due to the movement of the piston um, and so on, the deposit will compel from the chamber wall. Okay, so due to the porosity of the deposit during the combustion process, the deposit will break off and detach from the chamber wall. And the last one, due to the maybe the impact of the liquid fuel from the spray injector, and when the spray liquid fuel from the spray impinge on the wall that has a deposit layer, so this deposit layer will wash off from the chamber wall. So these are the processes involved with deposit formation and also deposit removal as suggested by Lepperhoff et al. 1993. Okay, factors that affect the deposit formation. First factor is the liquid film formation in an engine. Yamada et al. 2002 investigate in terms of deposit formation due to the fuel spray impingement. So the figure shows the bot, top view of the combustion chamber, where we can see for the first figure the arrow shows the direction of fuel spray that impinge on the inner surface of the combustion chamber wall. And the second figure shows the features of the inner surface of the combustion chamber. So from from this investigation, it is found that the area or the region where the fuel spray directly impinge will have more deposit formation compared to the others area, which means the area where have a higher tendency in terms of liquid film formation occur will have more tendency in terms of deposit formation. Okay, so you can see the area where the fuel spray impinge on the wall as shown in the figure will have more deposit, that represented by the black color area. Normally the result shown are based on clean combustion chamber. However, with deposit, however, if the engine already covered with deposit layer, the value or the result will be a change or will be slightly different. The second factor is the engine parameter. So as mentioned by ALPS 1990, so there are three engine parameter that affect the deposit formation. First, we have the compression ratio. When the compression ratio increase, amount of deposit accumulated in the engine will decrease. Engine parameter number two is the charge air pressure. So according to the result obtained by ALPS 1990, when charge air pressure increase, the deposit formation in the engine will decrease. The last one is the engine load. So when engine load increase, amount of deposit also decrease. So there are three main engine parameter that affect the deposit formation. First, we have compression ratio. Second, charge air pressure, and also the engine load according to ALTS 1990 investigation. The third factor is the engine operating condition. So an investigation conducted by Nagao et al. 1966. So he obtained the result in terms of deposit formation over time in an engine for different engine speed and also different combustion chamber wall surface temperature. Okay, so normally the temperature is based on combustion chamber wall temperature. So the wall temperature tested or investigated in this investigation are 400 degrees Celsius and 250 degrees Celsius, and the speed of the engine is at 600 rpm and also 1200 rpm. So if you compare in terms of speed of the engine, so lower engine speed will have more deposit accumulation in the engine. However, in terms of wall temperature, lower wall temperature will have more deposit accumulation compared to higher wall temperature. Okay, factor number 4 is fuel and also lubricant, type of fuel and also type of lubricant that we use in the engine, because due to the what I call the effect of lubricant that supply during the movement of the piston also will enter the combustion chamber, and part of the lubricant will cover the inner surface of the combustion chamber. Okay, in terms of fuel, because the what I call the fuel spray sometimes will impinge on the combustion chamber wall surface. The last one is the wall surface temperature. So you can see also the result obtained by IELTS 1990. The figure shows the relationship in terms of deposit mass versus piston temperature. So the data shows the numbers shows the different location of the piston in terms of deposit formation. So from the line that on the figure shows that when the piston temperature increase, deposit formation will decrease. Okay, so the result that obtained by ALT actually aligned with the result that obtained by Nagao et al. Engine problems due to fuel deposits. So first, fuel deposit at the injector tips. So the figure shows the cross section of the actual diesel engine. So we have fuel injector and also injector tips. So you can see that the difference between, so now we want to show the difference between the clean injector tips and also the injector tip that already covered is the fuel deposit. So figure 1 shows the clean tips. So we can see that very tiny hole shows the holes of the injector tips where diffuse spray will come out from these holes. And figure number 2 shows the clean holes, where in terms of diameter for comparison is 260 micrometer. And if you look at the figure 3, that shows the simplified cross-section drawing of the holes of the injector tips. So we have injector holes, fuse spray, and also injector tips. So we need to see this one in order to comparison between the clean holes of the injector tips and also the dirty holes of the injector tips. So now you can see figure number 4 shows the unclean tips due to the formation of fuel deposit on what I call injector tip surface. Okay, so if you refer to the figure of clean holes and also unclean holes that shows by figure number 5, we can see that the diameter of the hole reduced from 260 micrometer. So now because due to the formation of deposit layer at the holes, so the diameter reduced to 200 micrometer. So if you look at the schematic diagram, you want to know how the how the deposit layer form in the holes. So the schematic diagram in figure number 6 shows the features of deposit at the injector tips and also at the inner surface of the injector holes. So due to the formation of deposit layer in the inner surface of the injector holes, so this will altering the spray pattern. So figure number 7 shows the good injection or good spray pattern. However, due to the deposit formation in the holes surface, inner surface area, and also at the injector tips holes, so we'll have poor injection and also we'll have poor spray pattern as shown in the figure number 8. And this will result in this will reduce the fueling rate during the combustion process. Okay, problem number 2 is involved with fuel deposit formation at the piston top, where this fuel deposit will restricting airflow in the squish area. So squish means an effect in internal combustion engines which create sudden turbulence of the air-fuel mixture as the piston approaches top dead center (TDC). This effect is used to promote air-fuel mixing. So the figure shows the what I call the smooth air or fuel flow in the squish area without deposit. So at this condition, without deposit, so we can promote air fuel mixture, okay, due to the smooth air or fuel flow at the squish area. However, from investigation that conducted by Dan Lee et al. 2000, as shown in the figures, so the investigation found that the formation of deposit layer at the squish area will restrict air or fuel flow in the squish area where the deposit formation occur. So this will reduce I call the air fuel mixing in the combustion chamber. Okay, the third problem involves with fuel deposit at the combustion chamber wall, where surface heat transfer alteration will occur, as mentioned by Ishii et al. 2001, in terms of wall temperature and also heat release to surrounding. For the less deposit condition, so wall temperature and also heat release to surroundings is higher compared to the condition where the engine have more deposit, as shown in the figures. And also the effect on the hydrocarbon emission, where from the investigation that conducted by ELK 1990, so he shows that the relationship in terms of deposit accumulation in the engine with hydrocarbon emission. So he found that when hydrocarbon emission increase, the amount of deposit accumulation in the engine also increase. So this is probably due to the hydrocarbon that trap inside the deposit layer in the combustion chamber. So when the exhaust process occur, so part of the hydrocarbon inside the deposit will release through the exhaust pipe. Okay, that's all for this chapter. Assalamualaikum.